Good afternoon, and welcome to Looking Up, your source for astronomical facts, history, and current events. I'm your host, Samuel Singer from Wyoming Stargazing. Join us each week for a snapshot of what's viewable in the night sky, some science behind those objects, and a bit about the history of astronomy. This week's show is all about the Northern Lights. The incredible dancing lights that we sometimes see in the skies above Jackson are more often seen above the north and south magnetic poles. They are known as Aurora borealis in the northern hemisphere and Aurora australis in the southern hemisphere. These amazing displays of light are the result of collisions between electrically charged particles from the sun that interact with gases in Earth's upper atmosphere. The temperature at the center of the sun is 27 million degrees Fahrenheit. Near its outer layers, the temperature drops to about 3.5 million degrees. Enormous bubbles of plasma that are driven by rising and falling temperatures and the sun's magnetic field form at that layer. Above that layer of bubbles, on the layer of the sun that we can see in visible light, sunspots form, where the sun's magnetic field lines get twisted together and later unwind. That process can send huge amounts of solar material out into space, which joins the constant outflow of solar material called the solar wind. The solar wind carries those electrically charged solar particles towards the Earth, where they are mostly deflected by the Earth's magnetic field. However, the Earth's magnetic field is weakest at each of its poles, and therefore some particles enter the Earth's atmosphere at those locations and collide with gas particles in our atmosphere. These collisions emit light that we see as the aurora. Displays of northern and southern lights appear in many colors, including red, yellow, green, blue, and purple, but pale green and pink are the most common. The large range of color is due to the type of gas particles that are colliding at different elevations. The most common color, a pale yellowish green, is produced by oxygen molecules located about 60 miles above the Earth. Red auroras are produced by oxygen at elevations up to 200 miles. Nitrogen produces blue or purplish red aurora. The lights appear in many different forms, including rippling curtains, patches of scattered clouds, streamers, arcs, or rays of light that shoot up into the sky. The term Aurora borealis means dawn of the north. Aurora australis means dawn of the south. In Roman mythology, Aurora was the goddess of the dawn. In medieval times, the northern lights were seen as harbingers of war or famine. Native people saw the aurora as the spirits of great hunters and fishermen, of the animals they hunted, or as reflected light from torches or campfires. The connection between the northern lights and sunspot activity on the sun was first made in the 1880s. Research conducted since the 1950s has led us to understand that electrically charged particles, such as electrons and protons, from the sun are blown towards the Earth on the solar wind. We also know that solar activity peaks about every 11 years. During those times, there is more solar activity and consequently more northern lights on Earth and on the other planets of the solar system. The last peak in the solar cycle was 2013. While there is no way to know when the northern lights will occur more than a few days beforehand, we can watch the surface of the sun for large ejections of solar material. When that material, carried by the solar wind, reaches Earth about 40 hours later, we have a chance at seeing northern lights. We can expect that type of solar activity to decrease in the next couple of years. Thanks for listening to Looking Up. Join us next week to learn all about stars, planetary systems, and galaxies.